Good morning, student. Let's start today's class. Okay. In today's class, we are going to discuss about concentrating collectors. Previously, we have already seen about what about flat plate collectors. Okay. And the demerit of the flat plate collector is that the flat plate collector is or the flat plate collector cannot provide the high amount of heat energy which is required for some of uh, work or some of industries, and when we need much higher temperature which cannot be achieved by flat plates collectors, we use concentrating or concentrator. We use some concentrator to concentrate the solar radiation on the observer. That means, what is concentrator? You know, there's a reflector behind of your torch bulb. There is a parabolic reflector. Okay, that reflector also a concentrator. Concentrator means it concentrate all the scattering radiation, light radiation into one place, or it focus the light, scattered light, into one focusing point. Okay, that is called concentrator. Here in the collector, one concentrator are there and one absorber are there. And that concentrator concentrate the sun radiation to the on the observer. That's why the observer get higher amount of temperature. Okay. Oh, then let's consider one type of concentrator. What is parabolic concentrator? Why use parabolic concentrator? Why not use anything else? Because in parabolic concentration, in parabolic mirror reflects solar radiation which is parallel to the axis, to its axis, to its focus. That means we know from the uh, characteristic of parabolic reflector that it reflects parabolic mirror, it reflects the coming radiation which is parallel to the axis of that parabolic mirror, focus or reflect them to the focus point. Okay, here you see this is parabolic mirror. Okay, and this is the axis of the parabolic mirror. If these two rays are parallel coming from the sun, that they reflect to the focus. This is focus point. Okay, and from the uh, ground to the focus point, this length is called focal length. Okay, by using this property, by using these properties of parabolic mirror, we can construct concentrating collector. Okay, now let us see construction of a concentrator. Okay, the above figure shows the schematic of a concentrator. It is a parabolic concentrator. Okay, the in front of that parabolic concentrator an absorber uh, is there. Okay, or pipe like absorber is there. Okay, and this in parabolic concentrator have a tracking device that tracks the position of sun and always face to the sun Okay, and the axis of the mirror reflector should always point towards the sun constant in constant to flat plate. Acha. That means in flat plate collector, what happened? The sun is not always is not in the axis of the flat plate collector. Okay, that means it can the sun can be in an angle of that flat plate axis, so that the flat plate cannot get the maximum number of heat. Okay, but in the parabolic concentrator, the sun should be, or the axis of the parabolic concentrator should always face towards the sun. Okay, here you see, this is the axis of parabolic concentrator. So this parabolic concentrator is always in line with the sun axis. Okay, so that it can absorb efficient high temperature. Okay, efficiently high temperature. Okay, therefore towards and uh, to to and and to being always in the axis of the sun axis or sunlight, we should use an tracking device that tracks the position of sun and accordingly adjust the position of parabolic concentrator. Okay, and this tracking can be done by the device in the both axis. Means in horizontal way or in vertical way. That means the tracking device move the parabolic concentrator in both the axis, horizontally and vertically. Okay, and one of the difference between the flat plate collector and the concentrating collectors is that in flat plate collector, both direct ray and diffused ray or indirect radiation are received or used. But here in concentrating collector, only only direct ray or direct radiation is used. Okay, the observer the observer converts the incident solar radiation into maximum amount of heat and transfer it to the heat transfer fluid. That means the observer this observer have one pipe like structure. Okay, and inside the pipe there is a thermal fluid, thermal exchanger fluid. Okay, which exchange the heat received by observer to the working place. Okay, there are two types of observers. Okay, this observer may be or can be classified into two types. Okay, one is open observer, one is cavity observer. In open observer, the observing pipe uh, is opened or can be covered by a transparent material. Okay, and due to it is open, so that the heat loss also very high. Okay, but in case of cavity observer, the amount of the amount of uh, but in the case of cavity observer, the amount of openness or it possesses a very small opening for solar radiation, so that due to it has a very small opening, so that the heat loss is very low. Okay. Now let us discuss about what is throw parabolic throw collector. Okay. In parabolic throw collector, this is parabolic throw collector. Okay. The above figure shows a parabolic throw collector which track the sun only along the single axis. That means in you see a previous method the that the sun can be tracked in both the axis. Okay, but here in parabolic throw collector the sun can be tracked only in one direction. Okay, it can be tracked in this way. Okay, it cannot be tracked in this way. Okay, so the reflector are made up of mirrored glass. Okay, which is given a parabolic curvature. Okay, this is the reflector. Okay, and this is made up with curved glass and shaped as like a parabolic. Okay, the absorber is selectively coated in the tubular shape. Okay, this is the absorber, this tube. Okay, and it is coated with a black band to absorb maximum amount of heat. Okay, and this is the fluid pipe inside the absorber. From here the fluid in, and from here fluid out. Okay, heat transfer fluid such as thermal oil can reach temperature up to 393 degrees Celsius. 393 degrees Celsius, such a high degree Celsius, the fluid can be reached. Okay, such type of collector system are used either for electricity generation or for process heat generation. That means uh, this this what this parabolic throw collector can be used for electricity generation or for the process of heat generation. Okay, then see what is parabolid collector. Okay, parabolid collector. A parabolid collector with a rational symmetry is shown in figure. Okay, this is the parabolic collector. The This parabolic collector has a paraboloid paraboloid reflector and an absorber in front of that parabolic reflector at that the focus point of that parabolic reflector. Okay, and this parabolic reflector dish, okay, can be several meters. The radius or diameter of this parabolic dish can be several meters. Okay, the spherical shape is achieved by pasting small plane mirrors component and parabolic base on a parabolic base. That means this parabolic mirror can be achieved or can be made by pasting the plane mirror on a parabolic base. Okay, paraboloid base. Okay, the absorber is in the form of a sphere. Okay, this absorber is in form of the sphere. Okay, such paraboloid collector are normally used for power generation. Okay, then let us discuss about heliostats. Okay, heliostats. This is one of type of collectors. Okay, here the large plane mirror can act as concentrator known as heliostat. This is the difference from previously discussed parabolic collectors. This is not parabolic collector. This is plane mirror collector. So here the plane mirror can also act as a concentrator known as heliostat. This plane mirror which act as a concentrator known as a heliostat. The mirror are made up of 3 mm thick several silver glass. All heliostat have their focus onto the observer. Here you see this is one on heliostat. Okay, this little plane mirror. Okay, and the face is towards the observer. Okay, here the observer is there, one tower. Okay, and the tower and one observer in the top of the tower. Okay, and the all the heliostat, this is one heliostat, all the heliostat focusing or the facing towards the observer, and when the sun ray or the sun ray fall on the heliostats, they reflect that sun ray to the observer. Okay, thank you.